Hello, my name is Aaron Eskenazi, and this is my final presentation for Mr. Cross's first period conceptual physics class, Sound Tubes, Vibrations in Action. Before I could do my experiment, I had to make some observations, and I observed that pipes of certain lengths, longer or shorter, produce sounds that differed from ones of the opposite spectrum, shorter or longer. The question I came to was, how does the length of a pipe affect its pitch? For instance, do longer or shorter pipes have higher pitches? Using this question, I created the hypothesis: if I play the longest pipe on my pan flute, then it will have a higher pitch because it will be able to vibrate more in the tube due to its longer length, rather than a short one, which won't be able to. For my variables, I have my independent variables, the pipes being played, which will change. I have the dependent variables that are the climate and location, and the constant variables that are the pipes used and the person playing. For this experiment, I'm using two pipes, one that is 6 inches as my long pipe, and one that is 3.5 inches as my short pipe, and a computer program called Audacity to find the pitches of these pipes. The steps for doing this experiment go as follows. You will press record on Audacity and play the short note. Use Audacity to find the pitch of this note, and then do this twice more. Then switch to the long pipe. Here is an example of what you should do. This is the data table that I got from my tests, on the short pipe and the long pipe, and on my 3 different tests. All tests seem to range around the same numbers, roughly in multiples of 1,000. Here's the graphs that I have for both the short pipe and the long pipe. The numbers here are much larger than the numbers down here. My analysis is that the average for the short pipe is much less than the average for the long one, at 2.527. The long pipe has an average of 5.142, giving it a higher pitch. And the conclusion is that I was correct. The length of the longer pipe allowed the vibrations to travel more, giving it a higher pitch, almost double that of the short one. I also thought that if I played the longest one on my pan flute, it would have a higher pitch because it vibrates more in the tube. And this was correct. I was able to assert this because of the fact that vibrations continually travel, and that the sound in our ears might be smaller, but still more of a high pitch. The errors in this experiment were that there was a little bit of background noise that may have interfered. Also, the problem with the computer software, because it doesn't directly give you the highest point and it has to be eyeballed. Some extensions on this question could be asking if I would get the similar or the same numbers using pipes made out of plastic or even steel. And also, would this test be similar if I recorded the noises from a longer distance? I alone worked on this project, and I built this PowerPoint, tested my pan flute, and blew the notes, as well as the experiment. I hope you enjoyed this, and thank you for watching.